Let's have a look at question 3 in this video. So in the regression results from table 4, we have all the observations from week 2 of 2004 until week 48 of 2014. Now we have in model 6 a dummy variable iPhone, and this dummy variable has the value of 0 for the weeks before the release of the iPhone and the value of 1 after the release of the iPhone. So before going further, what would be the intuition here? Why would we use this dummy variable? Recall that we are regressing the change in the logarithm of the price of the stock of Apple. So the intuition is that if there is a release of iPhone on the market, then that's a signal for the investors that there's a source of revenue for Apple in the future, meaning Apple would be more profitable, meaning the demand for the stocks of Apple would go up, meaning that the price of the stock of Apple would go up. Hope you can see this chain of reactions. That's why we would like to know if this indeed is the case, if this is significant or not, that the release of the iPhone would lead to this chain of reactions, would increase the demand for the stock and the price of the stock respectively, such that the regression would take a different slope after the release of the iPhone. Now, if we go here to the question, we have the following. What hypothesis do we have? What's the name of the test? Do the test and give the conclusion. So same as before. Okay, so what we said is that we would have a change in the regression slope. The regression might have a positive slope. So so far, if we are regressing, for instance, actually, if we have a look over here, we have a negative effect of Google trend and of volume on the Apple stock price. So we would have a regression line based on these values that's going slightly down. But after the release of the iPhone, we might have the opposite. We might have a slope that's gonna go up, and we want to know if that's actually the case or not. So how would we do that? We include this dummy variable over here, the iPhone dummy, and then we take into account what's gonna be the effect of the release of the iPhone on the effect of Google trend, on the change in the logarithm of the price, and what's gonna be the effect of the volume of the shares traded after the release of the iPhone on the change in the logarithm of the price. So what we're actually doing, we're adding 3 more variables in the models, these ones, because we have these 2 variables in the model 5, we have them also in the model 6, but we add 3 additional variables to see if the regression parameters change. So we are doing a Chow break test. We are doing a Chow break test to see if there's a break in the parameter, in the regression, to see if the parameters will change their values. The coefficients will become different after the release of the iPhone, and we have to take this into account in the model. Now, because we add these 3 variables, first of all, let's try the hypothesis to have them clear. The hypothesis is that adding these additional variables, let's call them the coefficient C1, C2, C3. So coefficient C1 is equal to C2 is equal to C3 is equal to 0. So there will be no effect from adding these additional variables to the model, and the alternative is that at least one of them will be significant. At least one of them, one additional coefficient will be significant, such that there will be this joint effect of adding them to the model. Now, because we're adding variables to the model, our R-square increases, so we're going to do our regular F-test on R-square to see if the increase is significant or not. So we're going to compare the R-square of the full model relative to the R-square of the restricted model, divided by the number of additional variables, which are 1, 2, 3 additional variables in this case, over 1 minus R-square of the full model, divided by the number of observations. Let's have a look what's the number of observations. The number of observations is 568, minus the number of parameters in the full model, which is the independent variables in the full model, 1, 2, 3, 4, 5. And by the way, the explanatory variables are the ones that are excluding the constant. So we're not including the constant in the parameters. Keep that in mind. This does not go into the parameters. So minus 5, minus 1. Now let's substitute the R-square values that we have. We have the R-square of the full model. That's model 6. This is the R-square, 0.048. So we have 0.048 minus the R-square of the restricted model, which is model 5, with only 2 variables, 2 explanatory variables, and it has an R-square of 0.022, so that's 0.022, divided by 3 over 1 minus the R-square of the full model, which we just said is 0.048, divided by 568 minus 5, that's 563, minus 1, 562, and if we calculate this F value is equal to 5.12, 5.12. That's quite a high F value. We could compare it with the critical value, or we could also look at the P value of this F statistic change, whether the R square change is significant or not, because the F statistic that we did was a test on the change in R square, and we can see that it says that adding the variables in the model leads to a significant change in the R square. In other words, indeed, these coefficients add explanatory power to the model, meaning that there was a significant break in the regression. So we reject the null hypothesis. We say that we have a significant break in the regression, parameters, So our slopes, our effects of the variables in the regression should be readjusted, because this release of the iPhone changes the effects of the variables on the stock price. Significant break in the regression parameters after the release of the iPhone. And that's it. Hope this makes sense, and we are done.